All right, hello everybody. Welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly. We tried to start a podcast about procrastination, but we're putting it off in favor of this. I'm your host, Joel Moses, and alongside me, my fellow WebAssembly fan, Oscar Spencer. Matt's off this week. For those of you who tune into what we say on a regular basis here on WebAssembly Unleashed, we want to take a moment to thank you for that. We're here and we do this because of you and because we love introducing you to the minds behind such a compelling technology. But if it's your first time with us, welcome to the podcast that was built with a dream, a whiteboard, and a possibly unhealthy amount of bourbon. Make sure to like and subscribe. I'm super excited about our WASM community guest today, one of the most influential people in WebAssembly. But first, let me introduce you to someone who's equally as influential, I'd say, my compadre, Oscar Spencer. He's like WebAssembly, he loads fast, he crashes rarely, and he confuses most HR recruiters. Welcome, Oscar.
Yeah, all of that is absolutely true. Yeah, no, it's great to be here. It's another wonderful day in the world of WebAssembly. So yeah, I'm super excited about our guest today. I've been, a longtime fan of him and his work. So it's exciting to have him on for a conversation.
Absolutely. What's on your mind? Are you tracking anything that's impressing you this week?
I think the cool things that came out of WASM.io are really exciting. I think we're starting to see, okay, we're actually ramping up towards all the developments in WASI finally coming to fruition. So we're actually seeing, okay, this WASI Preview 3 thing is going to happen. Okay, we're gonna get async and streams. Like, these things are absolutely, like, finally they're on the horizon. They're actually going to happen. So that's all incredibly exciting. And then of course in just the core WASM world, like I gave a talk on WASM GC. That was super exciting to just sort of get through to other people who are actually just doing generation of WASM code and get other people's thoughts and feelings on the specification. Say, okay, yeah, this makes sense, or maybe this is something we should have thought of a little bit harder. So it's really exciting to see all these development taking place. But obviously the air is always electric after WASM.io. So
of course, everybody's energized. They go home with a lot of energy.
Yeah, a lot of people went home with not a lot of energy, but because they went straight from WASM.io to KubeCon. So.
Oh yeah. Maybe we should reconsider the scheduling of those events in such close proximity together.
Right.
Yeah. Well, that's great. Let's move right on ahead. I think it's time to introduce our special guest. We're going to bring him on now, Andreas Rosberg, former Google engineer, where he was lead on the V8 JavaScript engine, co-designer, author, and editor of the WebAssembly specification, two-time winner of the ACN SIG Plan Programming Languages Software Award, first for V8 and then for WebAssembly, and co-organizer of the hugely influential Dogstool workshops and seminars for WebAssembly. Welcome, Andreas. Thank you for joining us today.
Thank you for the invitation. Just a small correction, I wasn't the lead of V8, I was the lead of the language team within V8.
The language team. Yeah. Well, and again, we want to get to a topic that's of great interest to us, domain-specific language called SpecTec that you've been working on and what it's doing for WebAssembly. But I gave you a little introduction. Why don't you take a moment to introduce yourself to our audience?
Yeah, I'm a person who has been interested in programming languages in general for a long time. I've done research in that, did a PhD on that. I'm used to be more on the side of functional programming languages and programming language semantics and type systems in particular. That was my thing. And they're specifically module systems, so ML style module systems, very powerful with fancy type systems. But I also always was interested in the kind of implementation side of things. So I kind of oscillate between these two poles, if you want. And so eventually I ended up at Google, and eventually there I ended up on the V8 team as one of the, along with Deno at the time, we started the Munich kind of V8 team, right? V8, in case you know, was originally done in Aarhus by Lars Bach's team, and then it was migrated to Munich, and that's where we started working on it. And then the team grew there over time, and eventually we started working on WebAssembly there.
So I guess before we even get into all the fun WebAssembly stuff, just how did you find yourself falling down the functional programming rabbit hole? Because I know it happens to all of us in different ways, and I'm curious what your introduction was.
I wouldn't even know if I'd characterize it as falling down. It's like I really enjoyed it. I felt it was, for me, it actually was a revelation, right? Like when I started university, that was the time when I was naive and young and thought C++ is the best thing ever. And then I quickly learned otherwise. So yeah, it was during university, like first years of university, we started with Scheme, and then there was some lecture later that introduced like more modern functional languages, with all the fun stuff with pattern matching and interesting type systems and type inference. And that was kind of like, okay, yeah, why are we not all doing it like that? That seems like so obviously the right approach to doing things. And then I had a project at university which was based on standard ML. And that's when I got into language formalization as well, because standard ML has this completely formalized language specification, right? And it had that in 1990. So that was the kind of next revelation I had in my career, where I thought, okay, this seems so obviously the right thing. Why is not everybody doing that? Because before, like, you have compiler class, and yeah, everything is like super clear when you talk about syntax, and we know how to formalize grammars and parsers, and that's all like has been done for ages. But then you had to implement the other parts of the compilers, like a type checker, and that's basically, it's just some weird stuff people write down in prose, and nothing is well defined. And I was like very unsatisfied with that situation. So when I encountered standard ML after that experience, I thought, oh yeah, okay, finally there's a formalism that is kind of equivalent to what we do for syntax, that lets us define and explain what's happening here for type checking and also execution. And I found that fascinating. And that is naturally lends itself, because it kind of comes from that community, to functional programming as well. Because I mean, honestly, most of the innovations in programming languages over the last probably 3 decades have originated from functional programming languages. Really.
Shots fired. You heard it here
Wow.
first.
Wow, that's quite an assertion there.
That's actually just like, if you look at it more closely, that's actually a fact, I would say.
Yeah, we've definitely seen this. Especially, I think, if you look at recent features in languages like JavaScript and Python, they almost all come from functional programming language backgrounds, right? And it's also really interesting, like looking at JavaScript and seeing how JavaScript was trying to implement pattern matching and not break the rest of JavaScript was really fun to sort of watch and see them try to fit it in there. But I think, yeah, my experience was pretty similar to yours, of sort of being introduced to functional programming in college and just falling in love with it that way. I remember, I think maybe my second year of college or whatever, we had an assignment that was implementing red black trees, and we had to do it in Java. And they gave us the full implementation in Haskell. And it was like 4 lines of code, just like, pattern matching. And I was like, yeah, why is not everyone doing this? Like, this seems to be the way that we should write programs. So yeah, I definitely feel that.
Yeah, pattern matching is pattern matching in data types, a particular example of where the mainstream has really taken a long time to catch up. And my analysis of that is usually that it fell victim to the object-oriented ideology that was so big in the 90s, right? So that's kind of like the antithesis to that in a way, like the dual. So yeah.
I guess in the world of pattern matching within large data sets, though, things like R, hugely influential. We're kind of returning. We're kind of snapping out of the object-oriented phases and moving to things that are more functional.
Yeah, I think that has been going on for a while now, right? As people are more wary of certain things in object-oriented languages, and like not being super modular or not being a natural way to express certain things. And I mean, most mainstream languages are kind of take parts from everywhere and combine all these things, because you ultimately have all of them.
all languages can be modular, just not by default.
Yeah, and I think the thing that people often don't realize is that there can be different dimensions, right? So OO is very strong on extensibility, or so they claim, but it's really only along one dimension, which is like adding new cases of data, right? Whereas functional programming and pattern matching is the exact dual that's extensible in terms of adding new functionality, new functions, new operations without having to touch the existing code. And those are the two axes that like you really need. And for example, in a compiler, this letter axis is actually way more relevant, because if you want to add like a new phase to your compiler, then, well, it's very natural to express that as a new function that pattern matches over the abstract syntax. And combining these two in a simple and natural way is still somewhat an open problem. I mean, there are solutions to that. It's kind of has been called the expression problem, like achieving extensibility across both these dimensions at the same time. But I've yet to see like a solution that is understandable and practical for normal programmers that really is convincing, I guess. You can encode all that, but it becomes pretty ugly and hard to maintain.
Yeah, it's really funny that you say, functional programming tends to be very good for compiler development, because we just think in terms of, okay, I have this data structure and I'm transforming to a new one. Of course, I'm doing pattern matching. And you made me realize I don't think I know how to write a compiler not doing that. I think that's the only way I know how to do it. So maybe that'll be a fun challenge for me at some point, is to write an object-oriented compiler.
Well, you end up with the visitor pattern a lot, right? Which to some degree you can call the declaration of defeat, essentially, of object-oriented.
So you mentioned extensibility, and I'd like to focus in on that a little bit. Extensibility is far easier if you can formalize and if you can verify, and so that kind of dovetails into talking about what we want to talk about today, related to WebAssembly, which is SpecTec. We have a wide array of listeners to the podcast, and a lot of them skew towards the novice end of the spectrum. And so how would you describe SpecTec, what it is and what it does for a WebAssembly novice?
Right. So what it is, like from very high above, it's a domain-specific language, right? A DSL for describing the WebAssembly semantics, syntax and semantics. What exactly it does, maybe I should go back to to explain that, how the definition of WebAssembly actually works. So
yeah, let's do it.
So one thing that is sort of novel, at least as far as the mainstream is concerned about WebAssembly, is that the language specification is really fully mathematically formalized, right? And we have proofs of the soundness of the type system and things like that. And the methods we are using there, they are not novel at all. It's like what in the literature or textbooks on programming languages and programming language theory has been done for decades, really, like in an academic field. And that's what people there routinely do. When you write a paper on some ideas about programming languages, nowadays you usually formalize it in exactly this style. And the WebAssembly specification, I really try to keep with this completely textbook style, so that anybody who has kind of studied this kind of thing can immediately read it. It's like nothing magic going on there if you're familiar with the whole notation and everything. But of course, that is still a bit for specialists, right? So most programmers are sort of comfortable with reading grammars as a formalization for syntax, but they're not comfortable with reading reduction rules as a formalization of execution, right? So of course we had to cater for a broader audience, so we also had to define the same thing in like prose in the more conventional way you see in language specifications. So we have both these formulations in the spec, and they're supposed to be equivalent. But as a spec author or proposal author now, that means you have to do duplicate work, right? You have to write both of these formulations. And in particular, the prose one is extremely tedious to write, because it's like so repetitive and so stylized, and it's just like extremely verbose, really. And the same actually applies to code reviews. So for language features in WebAssembly, when you add something to the spec, we do code reviews, or everything is on GitHub, right? The whole spec's on GitHub. And code reviewing these kind of things is also pretty daunting. The prose, because it's so long and repetitive, but also the formalism, which is expressed in LaTeX inside the spec. And LaTeX is one of these write-only languages that is really not nice to read, especially since in this environment we're using there, which is the Sphinx document processor, you can't even use any form of macros or packages for LaTeX, right? So you really have to write out everything manually. I created some sort of hacky preprocessor that allows some form of simple macros, but that's also very brittle. And anyway, lots of extra work that's created by that. And then there's another thing. So one thing we cared about with the specification is not just formalize it, but also prove it correct, as I mentioned earlier, right? And doing that not just on paper, but actually have a machine verified proof. And the way you typically do that is you use like a proof assistant or a theorem improver, and a popular one in that community is COQ. But if you do that, then
COQ.
COQ, yeah.
Just to the listeners.
For the American listeners who get upset. So what people usually do then is, well, they look at these written rules in math and try to translate them to COQ in some way. And they're relatively, for most part, relatively well explored ways of doing that, but it's still like a manual process. So that ends up with you having yet another formulation of the same thing, right? And there's like a manual process there, and that they correspond to each other is also sort of like, you can eyeball it, but it's like, okay, maybe I made a mistake there, and what would that imply? So then you develop the proofs in COQ for soundness and things like that, and ultimately you have the result. But does that now actually transfer back to what's written in the actual document, right? You can believe it, but yeah, there's room for more error. Anyway, so there are all these things you have to do, all this manual labor and this uncertainty, and it's also not scaling well because it's so much work, right? And we have many proposals, and you have to repeat all this work for every proposal. And we kind of knew when we started with the spec, we already were thinking about this, like what would be a better approach of doing that, but we didn't really know how to. I mean, it was clear that we would like to have some kind of formalism that can automate some of that, but we neither had the resources at the time to invent it, nor was there anything ready off the shelf that we could use, nor did we really know what our requirements will be in the future, right? So, and it took a while. And so you mentioned Darkstuhl. That was actually a Darkstuhl 2 years ago when finally the stars aligned, and there were various researchers and research groups there talking about this problem. And we realized, maybe with our combined expertise, we can pull it off. So the people present there, among others, were Philippa Gardner and Konrad Watt. So they were the ones who did the COQ proofs, the COQ formalization. It's called the WASM-CERT project, if you want to look it up. And the other big group was Sukyung Ryu's group, who had worked on the JavaScript specification. And there they did some interesting thing, that they took the JavaScript specification and tried to extract from the prose an actual kind of interpreter.
Oh, backwards.
Yeah, sort of backwards. That's what everybody else is thinking as well, of course, right? So, and now we talked and kind of agreed, oh, obviously you should do it the other way around, right? You should have the precise definition, and from that you should generate the prose. So that's what SpecTec is then. It's the DSL that defines the whole syntax and semantics, and then it's kind of like a compilation pipeline with multiple backends that can spit out the LaTeX for the pure math. It can spit out the COQ, which is still work in progress right now, and it can spit out, most interestingly, the prose that kind of describes the thing equivalently. And that means that to define like the semantics of some instruction, instead of having to write a full page or more of like heavily marked up stuff, you just write like a couple of reduction rules, and that's also the only thing you have to code review. And yeah, so that is supposed to hopefully in the future cut down the manual labor quite severely, so helps us move faster, and it also helps us having much higher assurance in the correctness of the spec. Because now for the COQ proofs, for example, it's much clearer that they transport back to the formalism now, because they all come from a single source of truth, right? They're auto-translated into these different representations. And of course, you can still make bugs in the implementation there, but usually when you have bugs there, they show up much more systematically. And of course, you also have additional like meta level checking now in this tool. You can check all sorts of like superficial correctness of the rules. And similarly, the other thing we can do, which is pretty cool, so the prose, as I said, it's kind of like a compiler, right? So when we generate the prose, what we have internally is an abstract syntax tree that kind of describes the prose, and then just gets rendered into English. But you can just view it as a sort of interesting language, and you can execute that language. So that allows us to implement what I would call a meta interpreter, because it interprets this meta level language that we use to describe the actual language. So you can parse the WebAssembly specification written in this DSL, which gives you a whole bunch of functions and rules, and the meta interpreter can then expressed in this AST, and the meta interpreter can run those on some input, which would then be a concrete WebAssembly module. And with that, we can actually run the actual English spec, if you want, against the test suite. So we also have some confirmation that the prose you read there is actually correct, which it definitely wasn't before. There were like plenty of bugs in there because it's just, as I said, so impossible to get like correct, right? So I don't know. That was a long answer, sorry. But
no, very complete answer. So from the very top, though, this is a way to basically represent the specification in a way that allows you to formalize it, document it, produce tests, produce provers, all in one go, right? So that you have something you start with at the top, and it keeps everything else beneath it in lockstep.
It's like the single source of truth is like the slogan we use. So generating tests is something we're working on. That is another thing I haven't mentioned yet. So right now we can run against handwritten tests. But of course, another obvious like added value of this thing would be, we can now write a fuzzer backend that spits out tests. And this is not just like an ordinary fuzzer as they exist in like all the browser or engine vendors have tons of fuzzers, right? But they are pretty basic in the sense that they don't really understand the language much. But here we are now. This fuzzer can be completely informed by the language specification. It understands all the typing rules, the execution rules, so it knows in principle what the result should be for anything it's generating. So it knows what all the kind of variables are in like an instruction, right? Like, so it can generate the complete test matrix for an instruction, like all the interesting border cases and combinations of things, which you could write down by hand all manually, but that is like usually not realistic, right? So for a couple of instructions, we had some ad hoc shell script that kind of generates some tests like a bigger matrix, but in general that hasn't happened. So the current test suite for WebAssembly it's not bad, but let's say the coverage varies, right? Right. So, and the hope here is, so Dongjun at KAIST in Korea is working on that right now as his PhD topic, this test generator that will also give direct added value to implementers for having a much richer and more complete test suite.
Yeah, and so I really wonder, so this is going to take a bunch of work off of folks who are trying to, implement, at least write up these proposals. Do you think it's going to make WebAssembly proposals move any faster?
Ooh.
Yeah, I mean, that's the hope, right? So we haven't proved that. Remains to be seen. And I mean, honestly, at the beginning, I wouldn't be surprised if actually it slows it down a little bit for the first couple of proposals that try to work with this, because like a tool like that is complex and needs to mature. And right now, I mean, I won't lie, error messages you get are sometimes a bit hideous, or if you get them at all. So we fully expect that it will take some time to really pay back on that front.
For sure.
Yeah.
Plus,
and
there's no back end for politics yet. Oscar.
That would be an incredible.
Yeah,
That
wouldn't it?
backend would make me very excited.
Yeah.
Which, speaking of that, though, in terms of backends that make me excited, talking about the actual reference interpreter. So I know up until this point, there are some portions of the reference interpreter that can be generated by SpecTec. We're not at the point that all of it could be generated. And so sort of what is the path forward there? Is it possible to have the entire interpreter be completely generated?
Yeah, so that would definitely be my ideal in some future. So yeah, maybe to clarify, the thing we currently can do with this meta interpreter is we can execute execution, right? So we can generate execution if you want, the actual execution part of the interpreter. What it does not currently is like generating a validator or a parser. So I've done some work on generating a parser because that shouldn't be too hard, right? That it's kind of like known technology in a way. So I hope we can do that at some point. But validation is much harder. For those who are familiar with type systems, like with WebAssembly 3.0, we now have a relatively rich subtyping relation. And it's always a hard problem to turn like a declarative definition of subtyping, which usually has this transitivity rule, right? So if something is a subtype of something else, and that is a subtype of something else, then this holds transitively. You just have a rule for that, but that is not a way of algorithmically checking it, actually. So usually what you do when you work on this on paper, you have to have the declarative formulation, which is good for proving things about it, and then you have an algorithmic formulation, which is more like executable, and you need to prove them correct. And already this just proving them correct is pretty hard in general, but auto-generating it might even be harder. So this is like sort of still a bit of an open problem. Yeah. So what's happening right now is that for these parts of the of the semantics, we call out to the existing reference interpreter and its implementations of that stuff. And we also do that, I should mention, currently for some of the numerics part, especially the floating point primitives, which are also just ripped off the reference interpreter and not yet implemented in SpecTec, which is something I'd like to fix rather sooner than later. But yeah, that was kind of like priorities, you mean?
Yeah, I mean, I would be so excited to see this happen. Largely, maybe it's a little personal for me, but I get the dreaded email every now and again of these, oh, hey, we're trying to advance this proposal, and Oscar, we heard you know OCaml, so can you help implement this in the reference interpreter? And it's never the easy proposals, by the way. You know? And so, yeah, I would be very excited to see some forward progress on that. But I understand that that's going to take some time, and that's definitely okay. So tell me a little bit about sort of your wildest dreams for SpecTec. So obviously, you know, we're using it for WebAssembly now, but potentially, could you see other specifications picking it up?
Yeah, that's a question we get a lot, right? So other people asking, oh, can I use that for my language or my kind of thing? It doesn't even have to be a language necessarily. So SpecTec is actually, the DSL itself is pretty generic. It just allows you to define syntax and relations and functions. And in principle, there's a lot of stuff you could define with that. The one restriction being that the sort of primitive it has built into its syntax, the kind of meta-level operators it has, are exactly those that we need for the WebAssembly spec, right? So, and if you define something else, then there might be some other things you might need. So that is one part. And the other part, of course, is that these backends, especially things like prose generation and the meta interpreter, they make a lot of additional assumptions about how to interpret the specification they are seeing. So something like the LaTeX backend can basically handle almost anything you throw at it, but the interpreter backend has to have a bit deeper understanding of what's going on to do its job. And that will probably not carry over. This is very unlikely to carry over to other languages because kind of one thing it assumes it's, oh, okay, these rules can be interpreted as a stack machine, for example, right?
Right.
So while we believe that the general approach as an idea and sort of like methodology is definitely applicable to other languages or whatever, that's not necessarily the case for the implementation we have. although we also think that eventually it might grow into that, right? But we are not prioritizing that because we don't want to get too distracted right now with other things. There are people who have tried applying it to other things just as experiments, and they have worked to some degree. Like Nate Foster, a student, has used it to specify P4, which is this networking language.
Oh, wow. Yeah, we're familiar.
But yeah, that's not a priority right now. But in the long term, we would love to see that, right? Like learning our lessons. And this will probably also, even with WebAssembly itself, when it grows further, we will probably have to iterate on the design of this DSL as well and add more features. And maybe at some point it stabilizes sufficiently that we can open it up and open up it to a broader user base, which we might also benefit from in a way, right? If there's a broader user base, there might be more support for maintaining it.
Oh, yes.
Yeah. Yeah, my way of understanding or relating a new technology is especially as it relates to domain-specific languages, is looking at things in similar domains and comparing them. So I when I looked at SpecTec, I immediately thought of like Sail and Lim and some of those types of things, like Sail for SMT engineering. How does SpecTec differ from things like Sail and Lim?
It doesn't have any interest in kind of like things related to SMT solving. Because that's not relevant here. So it's more about really very syntactic definitions, right? So that you can write things like reduction rules and typing rules, which are all defined sort of like on syntax. You define syntax and you have rules over that syntax essentially. So that's the focus of this thing. But there have been other tools like that, right? So one example is Ott and Lam, which came out of Cambridge 15 years ago, roughly, or maybe even longer, which also tried to achieve something similar, but in a much more general way. It really tried to solve the general problem. And with WebAssembly, we realized that, that's just too hard a problem, right? So we really want to kind of specialize the hell out of it and rip off the advantage that we know the domain and the tool can actually make these assumptions, and we can tweak it in any way we like. And I think that was vital to make it actually realistic.
Got it.
Now, before we have to get close to wrapping it up here, Andreas, I'm dying to know. Up until this point, you've continued to, pour a ton of energy into WebAssembly and into the specification. What keeps you excited about it? At this point, like, is there anything tying you to it, or are you just doing it for the love of the game?
Well, yeah, I guess to some degree. Also, there's just like some commitments I made. So, I mean, the past, I don't know how many years I've been pretty busy with pushing through some of the proposals, especially the GC proposal, which I was the champion of, right? Which was pretty painful at times. But clearly, when did we start that? It was probably 2018, something like that.
It's been a minute on that one.
It has been a long time, maybe even longer than that. I mean, we first talked about it in the very beginning that we want to do something like that, right? But actual work probably only started late 17 or something. I don't remember exactly. So that took much longer than I anticipated. And we're in a similar situation with the stack switching thing, where I collaborate with some other academics, Sam Lindley, and some of his colleagues. So that also has been in the making now for, 5 years probably. Yeah, it must have been before COVID, because I remember one meeting we had in Japan, like not a WebAssembly meeting, but an academic meeting where we discussed this, and I came up with the original design based on effect handlers, and we took it from there. That probably also was 19, something like that. Maybe even 18. There was a Darkstuhl before that where we talked about it. Anyway, so yeah, that's another thing I really want to see completed, because these two features are kind of like as far as I'm concerned, the biggest gaps with respect to compiling more high-level languages to WebAssembly, right? Because they're simply, maybe stack switching even more than GC, because without stack switching, there are simply things you can't compile, right? Like, and yeah, my original motivation was always like, I like languages, I like writing compilers, but actually, truth be told, I don't like writing code generators. So my personal interest was, let's define this nice abstraction, and let do let more competent people do that work for me. Of course, I'm kidding, but only half. But yeah, so I want to reach that point where basically it can do everything I'm interested in a programming language. And now with the whole specification thing, that was the other kind of part that really got me interested, because since ever I saw the SML definition in the 90s when I was a student, I kind of thought we should be able to prove that this works in the mainstream, right? And this is what we set out with WebAssembly, and I think we're on a good trajectory there, but we have yet to prove that it's really maintainable long term, right? Which is where SpecTec comes in. So engineering, where it becomes an engineering problem, and we have to solve the engineering side of that.
Well, just kind of casting back and looking at, you said the mainstream, and I think that's a really important thing to note. WebAssembly arguably has gone mainstream, and it's gone in places where I don't think we originally necessarily foresaw that it was going to go. What's the most surprising thing about the rise of WebAssembly to you?
Well, actually, we always hoped it will go in places, right? So
sure.
The kind of background is that it was a bunch of us frustrated JavaScript engine implementers. That's my version of the story, right? And let's do the right thing, and let's do it in a kind of universal fashion that can be used anywhere and is not tied to the web. And when I wrote the spec originally, I made took care and made very sure that it's not tied to the web at all, or even JavaScript, right? So the JavaScript thing is a separate specification, and the word web appears maybe exactly once somewhere in the core spec in some editorial text, I guess. So the whole design from the get-go was very intentionally so that it's kind of universal in a way. So we actually hoped it would be used in other contexts. We saw that has happened with the JVM to some extent, right?
Right.
So we hope that we could be at least as prolific as the JVM. But since it's also more low level, we also hope that it can actually go to places where the JVM is not applicable.
Right.
And we are more than happy that this has actually happened. But to answer your question more concretely, like things that have surprised me. Well, first of all, I guess for a long time, it was a bit of a mystery what the embedded folks are doing with it.
Yeah.
Right. So that mystery has now been solved for me, since ever folks like Chris Woods showed up at the meetings and explained what they are doing with it and why, and that essentially they need to solve the portability problem, right? So they have this gazillion different hardware processors, and he explained that every time they have a new one, they have to re-implement their entire tool chain, and they were kind of tired of that, essentially. Yeah. So they have this as a nice abstraction. And that makes total sense, at least for the lightweight part of WebAssembly. The other thing that kind of I found kind of interesting is that people really discovered the sandboxing aspect of it, right? So, and they're using it for security reasons in a way that I had not totally anticipated. So there are people who need to take some C library, which they don't really trust being safe, some pre-existing C library. So how can I safely interact with that? Well, I compile that to WebAssembly, and then I compile the WebAssembly back to C, which is a rather roundabout way of instrumenting the original C code with extra security checks or safety checks.
Right.
But, well, it works, right? And it seems to be simple enough in terms of tool chains, so why not? I found fascinating.
Yeah. Well, that's fantastic. We're ticking down towards the end of time, but one more question. SpecTec is aimed at making sure WebAssembly remains, well documented, concise, and verifiable as a specification. WebAssembly's got a long way to go in order to be, deployed everywhere and achieve its vision. What area do you think you'd like to see the community work on next?
So one thing I would be interested in is like having really nicely packaged standalone implementations that are integrated into maybe OSs or something, so I can just run WebAssembly applications on the desktop, right? That seems like an obvious thing. And for a while, the JVM was kind of in that space. So there were Java applications, and you had to install the JVM, and it was all a bit of a nuisance. So maybe at some point we can be in a place where this is just part of an OS, and you can just run that like it's integral part of the browser today, right? That would be pretty cool from my perspective.
Yeah. I don't think you'll get any disagreement from us.
No, not at all.
Right. And yeah, in general, the whole toolchain situation is still a bit lacking on many fronts. I think you still need to be brave sometimes to put everything together. Right. I also hope that the component system will succeed and succeed without becoming a completely baroque solve all the problems of the world kind of thing, or a COM-like thing. I think there's still hope there. I think right now we're still on the right trajectory there. But these are the things that could easily be derailed, of course. So I mean, ideally, I would like this to be this more universal platform, infrastructure kind of platform that.
I think it's well on its way. We appreciate you coming in and talking with us today. That's all the time we have today, unfortunately. Andreas, thank you.
One thing I should mention as well, WebAssembly and hardware would be a cool thing.
Oh, yes.
Oh, yeah. We spend a lot of time dreaming about that where we're working. So, yeah, I don't disagree with that. I'm really impressed by the projects that I've seen to like render firmware for hardware in WebAssembly. I think that's a really cool area as well. Embedded is something I think both Oscar and I are really intrigued by. All right. Well, Andreas, thank you for joining us. A great discussion. I learned a ton. As always, thank you, Andreas. Thank you, Oscar. Before I go, a quick reminder, friends don't let friends console.log in production. It's a big application world out there. It's time to unleash the power and promise of WebAssembly. So for Andreas, Oscar, and myself, thanks for listening in. Be sure to subscribe for future WebAssembly news and views. Exiting with code 0. Take care.